Having covered carbs and lipids, let's take a look at proteins, the next major macromolecule. What do proteins do? Tons of stuff. Muscle contraction, remember? Movement of body, cells, and structures. That's how you get around. Remember, the skeleton doesn't move by itself. Muscles move your skeleton. Cell membranes. So the cell membranes themselves are phospholipid bilayers, typically. But all those receptors, remember all those the cell identity receptors on your blood cells, the MHC proteins, all those pumps, the sodium-potassium pump, potassium-hydrogen pumps, um, ion channels, those are proteins, okay? Fibrous proteins like collagen and keratin, those are structural. Those make up your body, okay? Remember, connective tissue, lots of collagen. Keratin makes your hair, your fingernails, lots of other structures in your body. Bones, remember the matrix is collagen. The hydroxyapatite is the mineral that hardens the bone, but the bone matrix is actually made of protein. Then there are globular proteins. These are the ones that are antibodies, hemoglobin, myoglobin, enzymes, hormones, transporters, pumps, etc. Globular proteins are the ones that wear a hard hat and carry a lunch pail and wear those work boots, punch a time clock. They're doing all this stuff in your body. Just briefly, let's talk about the four macromolecules again. Carbs, lipids, proteins, nucleic acids. Carbs, those are for immediate energy. Lipids, that's how you store energy. Proteins, that's what your body is made of, and that's what's doing all the work inside of your body. Carbs and lipids are mostly just energy, although they do make membranes and they're also cell surface markers. Nucleic acids, remember, DNA, RNA, mostly that's the instruction manual for your body, okay? So notice how in the lower left, protein, a big string of beads. Individual beads are amino acids, okay? Your body breaks them down and then builds new proteins from the amino acids. The fibrous proteins are the structural proteins. Globular proteins are the functional proteins. Requirements for protein. Nutritional value depends on the proportions of amino acids. Remember, there are the 9 or 8, whatever, essential amino acids that cannot be synthesized. You have to eat them. You can't make them. Other proteins you can make. Histidine, isoleucine, leucine, lysine, methionine, phenylalanine, threonine, tryptophan, valine. Those are the big 9. Although notice in the graphic, I guess the graphic down below is the same. People argue about how many there really are. I don't care. Cells do not store surplus protein. So you store energy as fat. You don't store protein. Protein is either broken down and metabolized, excreted, or you turn it into energy, as we'll see coming up. Complete proteins, so-called, are the ones that have the essential amino acids in the right amount needed to synthesize protein. So meats, cheese, fish, eggs, yogurt, soybeans, quinoa. You can talk about some foods that I think, like wheat and beans together, supply all the essential amino acids. You can look in nutrition, there are charts of these things, of the best proteins to eat together. You don't have to know any of that for this class. You might for other classes. And there you go, just add squirrel helper. Lasagna, Arkansas style. I have a friend who lives in Arkansas. He said that the legislature there actually passed a law making it legal to eat roadkill. Be careful if you ever go to a potluck in Arkansas. Maybe there's bat. Maybe it's pangolin. Who knows? Watch out. Nitrogen balance. So, rate of nitrogen ingestion should be about equal to the rate of excretion. That's nitrogen balance. Proteins are the chief dietary source of nitrogen. Excretion chiefly as nitrogenous waste, which are urea. As we'll see coming up, when you break down proteins, you get amino acids. When you break down amino acids, when you deaminate them, you end up with the nitrogen group, and the nitrogenous wastes are converted to urea and then excreted as urine. Positive nitrogen balance, this is where you're putting in more than you're excreting. Who does that? Well, children, of course, because they're growing. They're taking in more nitrogen they're excreting because they're actually building tissue with it, all right? Promoted by growth and sex hormones, testosterone, other estrogen. Also, pregnant women and athletes. So remember, pregnant women, you got that little parasite growing inside of you. So it's got stealing nutrients from you. And like Olympic athletes, the ones who are truly, building muscle and getting stronger, they might also have positive nitrogen balance. Negative nitrogen balance, you're excreting more than you're taking in. When would that happen? Usually that's not a happy sign. You're actually breaking proteins down for fuel. That's muscle atrophy. Glucocorticoids do promote protein catabolism in states of stress. That's why people lose weight when they're stressed, one of the reasons. And this could be a consequence of malnutrition. So if you're severely malnourished, you're going to have to start using your proteins for energy, and that's a very desperate situation. Look in the upper right-hand corner there. Yeah, two different causes for the same shape. And the bottom right-hand corner, just heartbreaking. That little kid is on death's door. Let's see all his ribs. Body is using protein for energy. That's desperation. So minerals are kind of a leftover category here. Calcium and phosphorus, you need those for your bones and your teeth. Remember hydroxyapatite, calcium phosphate. Phosphorus makes phospholipids, ATP, adenosine triphosphate, creatine phosphate. Buffers, remember the phosphate ion, nucleic acids. So you need phosphorus for a lot of things. Magnesium and manganese, cofactors for enzymes, those are important. Iron, essential for hemoglobin and myoglobin. Chlorine, you need it to make stomach acid, remember? Mineral salts, you need them as electrolytes, govern the function of nerve and muscle cells. That's sodium potassium pump, sodium channels, potassium channels, ligand gated, voltage gated, you know that. And regulate distribution of water. Remember, water follows solutes. And up in the upper right, you might wonder what's going on there. That's Hesperus and Phosphorus from Greek mythology. They carried Venus, and they alternated. That's why Venus was sometimes the evening star and sometimes the morning star. Oh, all these little trips into trivia. Dietary source of minerals, so vegetables, legumes, milk, egg, fish, and shellfish. Animal tissues have large amounts of salt. All right, remember, think about your own. You got sodium. You got the extra cellular fluid of your body. What are the two main ions of your ECF? Sodium and chloride. So normally, if you're eating animal tissue, you're getting plenty of salt. All right. Carnivores rarely lack salt in their diets. On the other hand, herbivores sometimes don't get enough. So that's why sometimes you'll see actually they'll eat dirt. And the reason is there are minerals in the dirt. That's also why if you look at feedlots or dairies or whatever, where they keep lots of big herbivores around, they have salt licks. Why? Because it's difficult for herbivores to get all the salt they need. That's the salt lick. They're in the bottom right, the Bonneville Salt Flats in Utah, where they set the world land speed records. And up in the upper right, we'll talk about how, like in hikers, a lot of hikers know you have to stay hydrated. A lot of hikers don't realize that you also have to make sure to maintain your electrolytes. We'll talk about hyponatremia, which according to the medical services at the Grand Canyon is the single most common cause for medical treatment at the Grand Canyon. Not dehydration, hyponatremia. Vitamins then, so body synthesizes some vitamins from precursors, niacin, vitamin A and D. Vitamin K made by flora in the large intestine, pantothenic acid, biotin, folic acid, produced by intestinal bacteria. Water-soluble vitamins C and B, absorbed with water in the small intestine. Remember A, D, E, they're not stored, by the way. Whereas the fat-soluble A, D, E, and K absorb dietary lipids, and they are stored in adipose tissue. Deficiency in excess, vitamin A deficiency is most common worldwide. That causes night blindness because you need vitamin A to make retinol. Remember, that was one of the pigments for your photopigments? Well, that was, yeah. So vitamin A deficiency leads to vision problems, causes night blindness, increased infections as well. And hypervitaminosis can be potentially serious. Don't eat polar bear liver. Some of the Antarctic explorers actually died from eating polar bear liver. It was so high in vitamin A. And you see that picture in the middle on the right. What's wrong with that picture? Well, actually, there are lots of things wrong with that picture, but you see the huge incongruity there? Polar bears, North Pole, penguins, South Pole. They would never see each other unless that penguin was seriously off course. And there's Kanab Point. Oh my god, there's Kanab Creek coming in on the left. That bright orange layer is what's called the Esplanade. You can see the massive thunderstorm there in the upper right corner. Thunderstorms at the Grand Canyon come up and go just in a blink of an eye practically. It's so cool because I stand there and I watch the sky turn black. The thunderstorm comes up, the sky fills with lightning, the crashing of thunder, the thunderstorm is right overhead, the wind's 40, 50 miles an hour, dumps water on me. I get completely soaked head to toe, but it's like 95 degrees outside. Thunderstorm lasts like 5 minutes, and 10 minutes later, I'm completely dry again. It's almost like nature said, hey, do you need a shower? Here, let me give you one. Okay, boys and girls, stay tuned for the next Metabolism PowerPoint lecture.